Hello, math fans. I'm back from Thanksgiving. Going to finish off this series on cribbage. I had a long drive to think about this. Again, I should say I am a math professor at UW, but I'm a teaching professor. I don't regularly do research, so don't trust me on any of this. But just a problem I thought about as I played cribbage with my son over the years, which is basically how many points if you took an entire deck, just to recap, and used cribbage rules to get points. And those where you can get points for four of a kind. And there's 13 ways you can do that. Four of a kind. Runs, there's a ton of ways you can do that, because you can get a run with, this one, that one. Pick this one. And the number of combinations is enormous, and that's why that's so big. So that would be one example of a run. Those cards, that would be worth 13 points. The total number is 4 to the 13th, because there's 4 choices for each. And then flushes. Now, technically, flush usually means every card in your hand is the same suit, but I guess we're saying you can pick up all of these, and that would be 13 points. The discrepancy I had, because I had only found one posting online. I'm sure someone's looked at something like this before. This particular problem is very obscure, so maybe not. But the post I saw online, and I really appreciate that somebody had made this Reddit post, had a different number than I got. The number they got was that there were 16,924 ways. And I couldn't find any other reference or post about this problem. But I was pretty certain what I had done was right. I had done a more general mathematical way. So I finally came back and thought of a couple more things, and I did find a couple things missing from the online post. And so then I more carefully checked. And so this is just a verification. And then I'll follow up with another video about, I actually took this result and generalized it as much as I could. And, that would be, I feel like this is maybe a publishable item. Maybe I'll pair up with a student in the future and we'll make this, or I'll ask our combinatorics department about this. But mostly this has me thinking about the saying, a few cards short of a full deck. And that might be me, a few cards short of a full deck. But I think this is maybe the first time anyone's ever correctly done this. So what I'll do in this video is just talk about verification, some of what I did. And I can't, I hate that I'm pointing out errors in somebody else's great work. If it wasn't for this work, I wouldn't have looked so carefully. So somebody went through and listed all of the possibilities. The truth is that's just really hard to do without making an error. The list is enormous. This isn't all of it. I cut it off. I was so impressed that someone had tried to do that. And it was I had gone through and checked, and I just did not find any errors. I had worked all my way up to the 5s, and then I spotted this. So how many ways can you do this? So this is for anybody watching this video. If you've watched the previous one, how many ways can you have an ace, a 2? Now, there's nothing wrong with this. This does add up to 15. This is going to be 2. This is going to make it 4. This is going to make it 8. And 7 makes 15. So that does make a 15. In fact, that's something you really could get in cribbage if you had 5 cards that made that. But now you got to count. How many ways can you get 2 aces? And you have to think about that. It's what we in math we call 4 choose 2, which is actually 6 ways. And you can just sit down and do it. Ace of spades, ace of diamonds, ace of clubs, ace of hearts. And you can have these 2 together, that's 1. You can have these 2 together, that's 2. You can have these 2 together, that's 3. You can have these 2 together, that's 4. These 2 together, that's 5. These together, it's 6. There's 6 possible ways. So there's 6 possible ways you could choose 2 aces. How many ways can you choose of 2? Well, there's 4 ways you can do that. How many ways can you choose of 4? Well, there's 4 ways you can do that. How many ways can you choose this for? Well, it's 4 ways you can do that. So this should be 6 times 4 times 4 times 4 ways, which is 384. And that was the first time where I saw a discrepancy. So unfortunately, that was a slightly undercount there. So let's keep track. I found 3 small things. So their number was a bit low by this much. So that needed to be added to their result. Add to their result. And we'll end this video. I'll just mention these 3 errors. I'll add the numbers we get from these to their result, and we're going to get the same thing. I was pleased to, and again, it made me more and more confident in my result. So then I was going through, I found, this is actually the last thing I found, but I knew I was short a few points, so then I looked kind of more systematically, and the person who did this did a very systematic approach, but they missed one right here. Ace, 2, 2, 2. They did a good job of like trying to list kind of in a systematic order. But there's another way you could get an 8 here. You can do 2 and 6. You can do 3 and 5. You can do 4 and 4, or you can do just plain 8. And the only reason I spotted that is because I was listing some of these, and my youngest son pointed out that I kept forgetting the case where it was just a number. So there are 4 ways you can do this. There's 4 ways you can choose 3 2s. There's 4 ways you can do that. So that's 4 times 4. That's another 64. So you were just missing that one. So we're short another 64. So we need to also add 64. So whatever this difference was, because they included the 96, but they needed to include that. And we also need to include the 64 for this missing one. And lastly, I then was so close to their answers were so tantalizingly close that I did a systematic search at that point, and I copied and pasted these into Excel spreadsheet, and I had to do some clever Excel work. Luckily, I know how to do that because I teach 400 students a quarter, so I always am working with large spreadsheets. But this one's a little off because if you get 2, 2, 2, 7, that definitely adds to 15. There's only one way you can have all 4 2s, and there's 4 ways you can have that. So that should have been a 4. So that was an overcount. So I need to, the difference between those is 12. They overcounted by 12. So I need to subtract 12. So I did all that, and I got this to be 340. And so then I took their result, their total, which was this 16,924. So I did 16,924. I added 340, and it was very satisfying that after a lot of checking, we were the same. But as I said, this is not to point out somebody's error. It's to say that without that other person's work, I wouldn't have figured this out. Because it made me really think carefully and question what I had done. And in doing so, I actually learned a lot more about the problem. So this is how math goes. We allow ourselves to make mistakes. That's really the point of these videos. I'm hoping along the way that I get to prove some things. I've been teaching for 20 years intensely. I have a lot of things I probably could have proved, papers I could have published. I just don't have time to do that. Now that I'm older, I don't know that publishing papers is going to help me at all. But I still would like to share problems. So I hope that's interesting to you. I think this is the answer. Maybe the first time ever published. I don't know. I'm sure someone could have figured this out if they'd put their mind to it. But that's the number of points you can get from a full deck of cards using cribbage rules to count your points. So that I'm going to stop this, but I have another video, which is what I learned from this is the challenge was adding up. What I think the real thing we learned is what are the different combinations and ways you can get sums? given some restriction. And I had encountered that in my past before, but this is a very specific one because you have certain rules about, like, all of these count as 10. This counts as 1. There's 4 of each. So it's a very specific opportunity to practice counting methods. And the interesting question in all of this was, how do you get 15? And once I'd come up with this method, I refined it a little bit. And now I can tell you all the sums, not just 15. So in the next video, I'll talk about this is basically what mathematicians do. If you give me a deck of cards, I can tell you how many ways you can get 31, how many ways you can add to 47, how many ways you can add to 322. I solved all those questions driving home from Thanksgiving. And then when I got here, I was like, it worked. So that's kind of how this goes. And that might have applications to other things. I don't know. So I'm going to stop this video, but watch the next one for a little deeper dive and more general result.